Hello bachcho, this is the second video of unit test 4. In this video we are going to discuss the question 16 to 30, the 15 questions, right? जिनके पास भी PDF नहीं है वो description में link दे रखा है, वहाँ से PDF डाउनलोड कर लो, right? So let's start doing the question करना शुरू करते हैं, ज़्यादा टाइम नहीं लगाते. Then let's question number 16. The radius of Earth is r and acceleration due to gravity on its surface is g. If a body of mass m is sent to height of r by 4 from the surface of Earth, the minimum speed with which the body must be thrown from the surface of Earth. So this is what is our Earth. The radius is r. We are sending a body to a distance r by 4, right? So this is the initial position and this is the final position, right? So the speed we have to find out. Let's say we throw this with a speed v. So then the kinetic energy will convert into the potential energy. So the half mv square, that is the kinetic energy, will be converting into the potential energy. So potential energy, how much is the final potential energy? Minus g m m upon this total distance कितना 5r by 4, so into 5r by 4 minus initial energy कहाँ पे a पे, so that is minus g m m by r. So this is what actually kinetic energy is equal to change in potential energy from b to a. So this m will be cancelled, right? This is minus plus and then 4. So this is half v square is equal to g m by 5r, right? G m by 5r. Now we know g is equal to g m by r square. So that will give us g m by r is equal to gr. So if we replace this, v square is equal to 2 by 5 gr. So the answer will be root 2 gr by 5, right? The next question, the escape velocity from Earth is 11 km per second, right? The escape velocity from a planet having another planet having twice the radius of Earth and same mean density, any density of another planet is same as density of Earth, right? So here we have to convert our formula in the form of density. What we know, the escape velocity is root 2 g m by r, right? So now if I convert the mass into the density, so this will be density into volume. Volume is 4 by 3 pi r cube upon r. This r will be cancelled. So this g and the density and all other parameters are constant. So VE और ये r square हो गया तो is proportional to r. So that will be V1 upon V2 is equal to, velocity of Earth upon velocity of planet is radius of Earth upon radius of planet. So velocity of Earth is 11, that is escape velocity from the surface of Earth. So this is radius of Earth upon twice the radius of Earth. So then escape velocity of planet is 22 meter per second. So that will be 22, right? So the next is the question number 18. Weightlessness experienced in a satellite is due to, that's a very interesting question. Weightlessness in a satellite, right? देखो, कभी भी कोई ऑब्जेक्ट फ्री फॉल में होता है तो वेटलेसनेस होती है. तो यहाँ पे क्या है, ये हमारा अर्थ है, ये सैटेलाइट इस ऑर्बिट में घूम रहा है, राइट? तो हम बोलेंगे ये फॉल तो कर नहीं रहा, ठीक है, लेकिन एक्चुअली इट इज इन ए स्टेट ऑफ फ्री फॉल बिकॉज ये जो फोर्स ऑफ अट्रैक्शन है, दिस इज एक्टिंग एज ए सेंट्रीपिटल फोर्स So that's why it is not falling. So it is not falling, but the state is of free fall. So this is free fall of spaceship, right? So that should be basically the satellite, you know? Anyway, you won't mind it. So this is because of the free fall state of this. The ratio of the kinetic energy required to be given to a satellite to escape the Earth's gravity to the kinetic energy required to be given to it so that it moves in a circle orbit. देखो, about the Earth surface. What is the orbital velocity? The orbital velocity is root gr. What is the escape velocity? That is root 2 gr. So velocity of escape is root 2 times of orbital velocity. Okay, so as the kinetic energy is proportional to square of speed, so the kinetic energy must be twice. So kinetic energy required to be given to is that twice. So we have to give the double kinetic energy, right? Because speed is root 2 times, so kinetic energy is square of that, so that will become twice. At what depth below the surface of Earth is the value of G same as that at a height of 5 km, right? The value of G at the depth is same as the value at height, right? For the depth, we have the formula G 1 minus d by r, the depth, and for the height we have the formula G 1 minus 2h by r, where g is acceleration due to gravity at surface. So this will simply specify d is equal to 2h. If height is 5 km, then the depth must be 10 km, right? A planet moves around the sun at a point P. It is closest to sun at a distance d1 and has a speed v1, and at another point Q when it is farthest from the sun, right? It is like this, that is the orbit of sun. The planet is point P, this distance is d1 and the velocity here is v1. There is some other distance, other point Q, which is farthest from the sun at a distance d2. So this distance is d2 and the velocity here is v2. So its speed will be, that's a very simple rule, v is inversely proportional to distance. So v1 upon v2 is equal to d2 upon d1, right? So what is v2? The v2 will be d1 v1 upon d2. So that will be d1 v1 upon d2, right? ये ग्रेविटेशन का क्वेश्चन है. ग्रेविटेशन के क्वेश्चन में बहुत ज़्यादा कॉन्सेप्ट्स नहीं होते, कुछ पर्टिकुलर कॉन्सेप्ट्स होते हैं, उन्हीं पे बेस्ड क्वेश्चन होते हैं. The next question, the distance of Neptune and Saturn from the sun and this assuming that they are moving, their time period are in ratio. We know the Kepler's third law, T square is proportional to R cube. The time period of Neptune to time period of Saturn is equal to radius of Neptune to radius of Saturn to the power 3 by 2. The radius of Neptune is 10 to the power 13 and this is 10 to the power 12. So what is left? Only 10. So that is 10 to the power 3 by 2. That is 10 cube upon this 10 का cube करेंगे 1000 and then square root करेंगे, so that will be 10 root 10. So that will be our answer. Two bodies of mass 10 to the power 3 kg and 10 to the power 5 kg are separated by a distance of 2 meters. At what distance from the smaller body will the intensity of gravitational field will be 0? These are the two bodies A and B, right? So this is mass 10 to the power 3, this is mass 10 to the power 5. So let's say this is the point where intensity of gravitational field is 0, that is at distance x. So this remaining point is 2 minus x. Now the field due to this will be EA and the field due to this will be EB. For the net field to be 0 at this point, at the point O, the two fields must be equal. इस पॉइंट पे फील्ड 0 होने के लिए ये दोनों फील्ड इक्वल होनी चाहिए. So EA should be equal to EB. The formula of the field is GMA upon RA square, GMB upon RB square. G तो कैंसिल हो गया. Now MA is 10 to the power 3, RA is x square, MB is 10 to the power 5, RB is 2 minus x square. This is, इसका रूट कर दो, 1 by x is equal to 10 upon 2 minus x. So इसको हम सॉल्व करेंगे तो 2 minus x is equal to 10x, तो x is equal to 2 by 11. Right? Is there any option? Yes. So that will be the option 2 by 11. Right? Question number 24. The radius of Earth is r and its angular velocity of rotation is omega. If the Earth suddenly stops rotating, then the change in value of g at a place on the equator will be. This is the effect of rotation on the acceleration due to gravity. Because of the rotation, acceleration due to gravity on surface of Earth is g minus r omega square cos square lambda. So that is the effect of rotation. So if Earth stop rotating, so that will be the change in g because of the rotation. At equator, this latitude lambda is 0. Lambda क्या है? Latitude. So the change in g will be equal to r omega square. So that will be the change in g, right? A body is projected away from the Earth with a speed 3 VE, where VE is the escape velocity. The speed of the body at infinity will be. What we will apply? We will apply the conservation of energy. The total energy at the surface of Earth and total energy at the infinity. So kinetic energy plus potential energy, kinetic energy plus potential energy at surface is equal to kinetic energy plus potential energy at infinity. How much speed we gave? Half m, 3 VE square, right? And the potential energy at Earth is minus g m by r. What is kinetic energy left at infinity? That is half mv square. We have to find the speed. And potential energy at infinity is 0. Okay. Now, VE is equal to root 2 g m by r. So if I make square, VE square is equal to 2 gm by r. So gm by r will be VE square by 2. So if I place here this gm by r, so you get 9 by 2 mve square minus. I place the value of g, that is mv square by 2 is equal to half mv square. So half m cancel हो गया. So v square is equal to 8 ve square. Then v is equal to 2 root 2 ve. So that will be the speed left at infinity, right? So this will be the speed left at infinity. Basically हुआ क्या? एनर्जी तो कम चाहिए थी, हाफ एम वी स्क्वायर. कितना एनर्जी चाहिए था? हाफ एम वी स्क्वायर. हमने दे दिया कितना? 9 by 2 एम वी स्क्वायर. तो 8 एम वी स्क्वायर एनर्जी तो बच गया ना. तो अकॉर्डिंगली इतना एनर्जी बच गया, तो इस वजह से स्पीड हो गया उसके ऊपर. 11. A current carrying wire is placed below a ये coil और ये current carrying wire है A and B. the current is flowing A to B, then the current in this, right? Now, and this current increasing, the current is increasing. Then if I apply the grip rule, then the magnetic field where here will be outward. यहाँ पर magnetic field outward आ गई. This magnetic field is increasing because the current is increasing. As the current is increasing, the magnetic field is increasing. और जब field increase होती है तो उसके opposite field produce करेगी coil. तो coil field किधर हो जाएगी? Coil field. That is inward. For inward field to produce, the current should be clockwise. That is clockwise. ये clockwise होगा तो जो field of coil होगी that will be inward. So this way the current should be clockwise. A clockwise current will be induced in the coil. The question number 12. Two circular loops, दो circular loops है P and Q, are placed parallel to each other. A current is flowing through P. A current is flowing through P. इसमें current flow हुआ P. And this current is increase. ये current increase हो गया. ये current increase हो गया तो magnetic field increase हो जाएगा. Magnetic field increase हो गया तो EMF induce हो जाएगा. वो क्या करेगा? Magnetic field को decrease करने की कोशिश करेगा. और magnetic field कब decrease होगी? जब ये दोनों दूर दूर चले जाएंगे. So what will be that? The loops will repel each other. तो loops एक दूसरे को repel करेंगे. Simple rule है. दूर कर देंगे magnetic field कम हो जाएगी. क्योंकि करंट बढ़ रहा था तो मैग्नेटिक फील्ड बढ़ रही थी और लेंज लॉ के हिसाब से उसका अपोज. व्हाट इज द अपोज? मैग्नेटिक फील्ड कम करो. मैग्नेटिक फील्ड कम कैसे होगी? दोनों का डिस्टेंस बढ़ा दो. तो इसलिए ये दोनों एक दूसरे को रिपेल करेंगे. नेक्स्ट, इन द फिगर फ्लक्स थ्रू, ये कोई सर्कुलर लूप है, इसमें एक रेजिस्टेंस कनेक्टेड है एंड यहाँ पे इनवर्ड मैग्नेटिक फील्ड है. ये रेजिस्टेंस है R. It is given that flux phi is equal to 6t square plus 7t plus 1. That is milliweber, right? And t is the second. The magnitude of induced EMF at t is equal to 2. Induced EMF निकालना है and direction of current. Current की direction निकालना है. तो पहले तो induced EMF निकाल लेते हैं. माइनस डी फाई बाई डी टी. माइनस साइन तो होता है डायरेक्शन के लिए, तो इसको ड्रॉप कर दो. तो डी फाई बाई डी टी कितना हो गया? 12t प्लस 7. डी फाई बाई डी टी के 12t प्लस 7 एंड टी इज हाउ मच? 12. तो 24 प्लस 7 दैट इज 31. तो 31 मिली वोल्ट हो जाएगा, राइट? तो या तो ये होगा आंसर या ये होगा. अब लेफ्ट या राइट? नाउ दिस फ्लक्स इज इंक्रीजिंग विद टाइम. The flux is increasing with time and the magnetic field applied is inward. तो coil field, जो coil की field है वो outward होनी चाहिए. और outward field कब होगी? जब anti clockwise current flow करेगा. तो current anti clockwise, तो यहाँ ऐसे आया, यहाँ ऐसे आया. So when the current is going left to right, right? The next is, this is a figure. An electric potential will be induced between the ends of the conductor as shown in diagram when it moves in. So basically this is what? ये कुछ poles हैं दो और यहाँ पे हमारे पास एक rod है, right? इसको हम move करा रहे हैं ऐसे, ऐसे, ऐसे और ऐसे. तो किस डायरेक्शन में EMF इंड्यूस होगा, राइट? सो देखो, EMF इंड्यूस होने के लिए जो कंडक्टर है दैट मस्ट कट द फील्ड लाइंस. फील्ड लाइंस को कट करना चाहिए. तो आप किसी भी सिस्टम में देखो, ऐसे मूव कराओगे या ऐसे मूव कराओगे तो वो फील्ड लाइंस को कट नहीं करेगा, राइट? इट विल कट ओनली द फील्ड लाइंस व्हेन इट विल मूव लाइक दिस. ऐसे मूव करेगा. सो दिस इज व्हाट इज द डायरेक्शन M. So when it is in direction of M, then only it will cut the field lines. A copper disc of radius 0.1 meter is rotated about its center. Radius is 0.1 with the frequency is 10 in a uniform magnetic field. Magnetic field is 0.1 with its plane perpendicular to EMF. The EMF induced when a disc or a metallic conductor, एक डिस्क हो, मेटेलिक डिस्क हो या एक मेटेलिक कंडक्टर हो, इनको हम ऐसे रोटेट कराएं अबाउट द O. सो देन EMF induces कितना, half B L square omega. In the case of disk it is R, so let's take it R, half BR square omega. So that is half. B is 0.1, R is 0.1 square, omega is 2 pi and F, that is 10. This 10, 10, 2, 2. So this is pi by pi into 10 to the power minus 2. So that will be pi into 10 to the power minus 2 volt. So these were the question from 16 to 30. In the next video we will have the question 31 to 45. Right. Thank you for this.